Okay. Now consider the orbital. That is, first one, s orbital. S orbital is a spherical. There must be one circle is there. That should be s orbital. There must be no directional nature that should be present in s orbital. Okay. Then consider p orbital. P orbital, that should be p orbital are basically three types. One is px, other is py, and third one is pz. At px, that should be the lobe is present in the x direction. Py, that should be the lobe is present in y direction, and z, that should be lobe is present in z direction. We can say the electron density present in this lobe, and middle of the two lobes is the space is called node. There is electron probability is 0. We cannot find any type of electron from the language of quantum mechanics. We can say the finding of electron probability is 0 at the space of node, that is the space between of two lobes. Then we come, that is d orbital. D orbital are, that should be 5 types. One is dxy, dxz, dyz, dx square minus y square, and dz square. Dxy, that should be placed in xy plane. Dxz, that should be placed at xz plane, and dyz, that should be placed at y, that is yz plane. Then we consider dx square minus y square. That must be dx square minus y square, that should be present basically x square minus y square. How we derive? That should be defined type. We can use some calculation, then we can observe that is dx square minus y square. And dz square, that is also come from some calculation, as for example some plus minus combination, then we derive that is dz square. Okay. There must be in the middle portion, there must be probability of finding electron, that should be 0. Okay. Then we consider some diagram, that is CSIR means wave function, and CSIR their square, that should be we get only positive value. That's why we use CSIR. For first one, that is 1s orbital, we get this curve, and 2s orbital there must be two lobes, plus and minus. Okay. But when CSIR is there, there must be 1s is more curvy nature. Okay. And in second one, 2s, there must be no negative slope. There must be both are positive slope. That's why we use CSIR. That must be square term of CSIR. Okay. Then we have to know that is node. Node means there must be electron density, that should be 0. Electron density, that should be 0. We cannot find electron density. So that must be radial node, angular node. Basically two types of nodes are there. That should be radial node, means n minus L minus 1. N is the principal quantum number, L is the azimuthal quantum number, and minus 1. And L is the angular node. Okay. And total nodes means what? That is n minus 1. The principal quantum number direct minus 1. Then types of orbital, number of peaks and number of nodes. If s orbital, number of peaks, that should be n. Number of peaks, that should be n. Number of nodes, that should be n minus 1. Okay. Type of orbital is p, that should be dumbbell shape. Number of peaks n minus 1. So number of nodes minus 1 again, that is n minus 2. That is number of peaks minus 1. That should be number of nodes. That is must be for d orbital, number of peaks n minus 2, number of nodes, that means n minus 3. F orbital, that is number of peaks, that should be n minus 3, that number of nodes, that means n minus 4. The orbital angular momentum of an electron, that should be called root over L into L plus 1 into h by 2 pi. We can derive root over L into L plus 1 h cut. H cut means nothing but h by 2 pi. We can say h cut equal to h by 2 pi. And L means azimuthal quantum number. L value is 0 to n minus 1. If there must be n equal to 2, so L value 0, 1. Okay, less than n. Okay. If L equal to 0 for s orbital, If L equal to 2, obviously that should be d orbital. L equal to 0 for s orbital. L equal to 1 for p orbital. L equal to 2 for d orbital, and obviously L equal to 3 for f orbital. These are very useful for determining term symbol. Okay, magnetic quantum number, that should be called M or ms. That should be value is minus L2 plus L. That is the range. That is 2L plus 1. Number of orbitals in each subshell, that should be 2L plus 1. L is the quantum number, azimuthal quantum number. And magnetic quantum number, that should be M. Value is minus L2 plus L. There must be subshells R, S, P, D, F. So, subshell S, orbital 1,